Welcome to this channel, and in this video we are going to be looking at critical points part 2. We are going to look at how to determine the maximum and minimum points, especially that of the relative minimum, relative maximum, absolute mean and absolute max. And it is important to note that these points are also known as extrema points or points of extremum. That's the plural. Okay, so first of all, look at the relative max and mean. Relative max and mean. This is very easy. You've watched a video before this one. We looked at how to determine critical points. But in this case, you now want to apply it to differentiate with the critical points you have gotten. Is this one the minimum or is it the maximum point? So I would want to illustrate this so that you would have a clearer understanding. And before I go into that, you should understand what relative minimum or relative maximum is all about. So if we have these two graphs now, right, and one is going like this, points here, let's call it C, and the output will be F comma C. This is actually the relative maximum because it is the highest point within this neighborhood, because all other points by the side of these points are less than the value, because you can see at this point there's a value at this point, right? There's a value at this point, but at this point that's where you have the highest value. Are you following? Then in the case of this graph that goes this way, sorry, there is not, so this is the minimum. This is also known as the relative minimum. Is a kind of like a value and is the lowest point within the neighborhood of this C comma FC, which in this case is the minimum point. All other points are higher than it, but is the lowest point across that particular interval that is given. So how do you determine when you've been able to get the critical point? Remember in the first video we said that to determine the critical point, you first of all get the first derivative and then equate the first derivative to 0, right? So how do you know if it is minimum or maximum? So now let's consider the graph of y equal to x squared. I want to be fast, and then let's label this as 1, 2, 3, 4. I just want you to understand, nothing much, so that any way it is put you will get it. So this is 2, this is 4, let's say this is 6, this is 8, and this is 10. I'm using a different scale here. So at x equal to 1 for the graph y equal to x squared, 1 squared is what? 1. Do you agree? 2 at x equal to 2, the output will be 4. This is the y-axis, this is the x-axis. And at x equal to 3, let me trace it up there. We have 9. At x equal to negative 1, negative 1 all squared is going to be what? 1. Negative 2 all squared is going to be 4. Negative 3 all squared is going to be 9. And then at x equal to 0 is still going to be 0. So you find out that you have a graph that is going like this. So what can we use to now know the condition for which a graph attains a relative minimum point? So in this case now, what happens here? If you have x squared, right, you have x squared over here, and then if you have to find the first derivative of x squared, that's f by 1 of x. If you differentiate x squared, what are you going to get? 2x. So if we determine the slope at x equal to minus 3, if you substitute minus 3 in the slope, you'll find out that that's the slope at this point, minus 3. 2 times minus 3 is minus 6. That means the slope at this point is minus 6. At minus 2, the slope is minus 4. At minus 1, the slope will be minus 2, right? I'm just substituting minus these values in the slope. At x equal to 1, it should be 2. So what do you notice here? You can see that the slope values are continually increasing from minus 6 to minus 4, from minus 4 to minus 2, like that. Are you following? So from this now, we can say that the rate of change of the slope must be what? Greater than 0 for a function to attain a what? A minimum point. Are you following? Then if it's in the case of maximum, and another thing you can also see here is that at the left hand side, you can see that the slopes are negative. So the slope transitions from negative through 0, because at this point what happens? The slope is 0 and then to positive. So mainly what we'll be using is the second derivative test. And then if it's in the case of a maximum, let's see the graph of y equal to negative x squared. I'm not putting the negative x in brackets, it's out. You get. So let's do the same thing. 1, 2, 3, negative 1, negative 2, negative 3. So let's say 2, 4, 6, 8, negative 2, negative 4, negative 6, negative 8. So if we now substitute 1, you find out that the output will be what? Minus 1, which is here. At 0, it will still be 0. At minus 1, that will be minus 1 squared, which is what? Minus 1. At minus 2, minus 2 squared is for them because of the minus. Are you following? So at the end of the day, you find out that it's something like this. Do you understand what's happening here? So it's achieving a relative maximum point. And then if you should get the slope of y equal to negative x squared, what's it going to be? It's going to be negative 2x, right? So if you substitute these values, like x equal to negative 1, at x equal to negative 1, let's start from negative 2. At x equal to negative 2, the slope is 4, because if you substitute negative 2, you have 4. At this point is 2. At this point is what? 0. At this point is minus 2. At this point, I'm substituting into this. At this point is what? Minus 4. So you can see that the slope is continually what? Decreasing. So therefore, we can say that the rate of change of the slope is less than 0 when a function achieves a relative maximum point. Are you getting it? So let's take some questions now. So let's say you are asked to determine the max or mean of the graph f of x equal to x squared plus 2x plus 1. Very simple. Get the first derivative, because a function achieves a max or mean when the first derivative is what? 0. So if you differentiate this, the 2 comes down, right? So it becomes 2x plus 2. So you equate 2x plus 2 to 0, and that will be that 2x is equal to minus 2. Dividing through by 2, what happens? You have that x is what? Minus 1. You've gotten the critical point, x equal to minus 1. So you go back to the original function to get the output of minus 1. So f of minus 1 is equal to what? Minus 1 squared plus 2 into minus 1 plus 1. Minus 1 squared is 1. 2 times minus 1 is what? Minus 2 plus 1. And at the end of the day, 1 minus 2 is minus 1 plus 1, which is 0. So we can actually say that the critical point is minus 1 or 0. Now the question is it a maximum or minimum point? Given this now, the first derivative, we got it as 2x plus 2. So if we should get the second derivative, what's it going to be? It was 2x plus 2. So second derivative will be differentiating the first derivative. So if you differentiate this, you're going to get what? 2, right? Do you understand? Or we can say 2x to the power 0. And then even though we substitute the value of x as minus 1, you still find out that negative 1 to the power 0 is what? 1. So at the end of the day, you still have 2. And then since the second derivative of x is greater than 0, in this case we got 2, that means it's a minimum point. And if you should see that on the graph, this is the graph of the curve, you can see that is a minimum point here. And where does it occur? At minus 1, 0. Can you see it? Right. So let's look at other questions. Stepping up. So let's say we are given this to solve. F of x is equal to s cubed minus 3 minus s squared minus 5x. And you are asked to determine the relative mean. Right? And max. So you are asked to determine the relative mean, because in this case you can see it's a cubic function, and most cubic functions attain what? Minimum and maximum values at the same time. right? Unlike the first one that was quadratic. So if you first get the first derivative, it's going to be what? 3x squared minus 2x, right? Minus 5. And if we should solve this, we now equate the first derivative to 0. That will be 3x squared minus 2x minus 5 equal to 0. Look for two numbers that will multiply, that have negative 15, and that we are adding to get negative 2, and that's simply 3 and minus 5, right? Because 3 minus 5 is what? Minus 2, and 3 times minus 5 is what? Minus 15. So that's 3x squared plus 3x minus 5x minus 5 is equal to 0. On factorization, what are you getting? That will be 3x into x plus 1 minus 5 into x plus 1 is equal to 0. Bring things together. That will be 3x minus 5 into x plus 1 equal to 0. Equate each component to 0. What are we getting? 3x minus 5 is equal to 0, or x plus 1 is equal to 0. So when the negative 5 crosses over, that means 3x will be equal to 5. Dividing through by 3, or x will be equal to what? Negative 1. Are you following? So these are the two points of x for which you are having a critical point. So you will now substitute each of these values into the original function, right? And what is the original function? X cubed minus x squared minus 5x. So f of x is equal to x cubed minus x squared minus 5x. So substitute each of these values. So f of 5 over 3 will be what? 5 over 3 to the power 3 minus 5 over 3 squared minus 5 into 5 over 3. So on opening this up, 5 to the power 3 is 125 over 3 to the power 3 is 27 minus 5 squared is what? 25. 3 squared is what? 9. Then minus 5 times 5 is 25, and then over 3. And if you should get the LCM of this, what is this? It's going to be 27, right? 27 divided by 27 is 1. 1 times 25, 125 is 125 minus 27 divided by 9 is 3. 3 times 25 is what? 75. Very good. And then 27 divided by 3 is 9, right? So 9 times 25 is what? That's going to be 5, 4. 9 times 2 is 18. 9 times 2 is 18, and then plus 4, you have 225. So what is 125 minus 75? That's going to be 50, right? So we're going to have equal to 50 minus 225 over 27, which is a negative 175 over 27, right? Negative 175 over 27. And then at, remember the other points we got was what? Minus 1, right? Minus 1. So at f minus 1, remember that the original function is what? S cubed minus x squared minus 5x. So at minus 1, you have minus 1 to the power 3 minus 1 squared minus 5 into minus 1. Minus 1 to the power 3 is what? That's minus what? Minus 1 squared is 1. Minus 5 times minus 1 is positive 5. And then that's negative 2 plus 5, which is actually what? 3. So the two critical points are what? Minus 1 comma 3. And when we substituted 5 over 3, we got negative 175 over 27. So which of them is the maximum or minimum? That is where the question comes. So now you will now differentiate the first derivative again. Remember, when we got the first derivative, what we had was 3x squared minus 2x minus 5. 3x squared minus 2x minus 5. So if you differentiate it again, what are you getting? So that's going to be 6x minus 2. We differentiate the first derivative again, which is the second derivative. Then substitute each of these s values. You can see that at s equal to minus 1, what happens? That will be 6 into minus 1 minus 2, which is what? Minus 8. I substituted the first value, minus 1, and then at second derivative of at x equal to 5 over 3, which is the other point, sorry. That will be what? 6 into 5 over 3 minus 2. 3 into itself 1, 3 into this 2. 2 times 5 is what? 10. 10 minus 2 is what? 8. So you can see that at this point, the second derivative is negative, while at 5 over 3, the second derivative is positive. And we said that if the second derivative is positive, then that means that it has a minimum point. But if the second derivative is negative, that means it has attained a what? A maximum point, as I explained earlier. So this is the relative max, while this is the relative mean. So graphically, if we have x cubed minus s squared, let me get it. If you have x cubed minus s squared minus 5x, this is what you have it. Now you see the graph, you can see that the first critical point was at what? Minus 1 comma 3. And then if you check the other one, you can see what is going on here. And now remember that our value was what? 5 over 3, and 5 over 3 is what? 1.67. And so by the time you convert negative 175 over 27, by the time you convert it to decimals, you have negative 6.48, which is the same thing with what we had earlier. Are you following? So now let's move on. And then another important thing to note here is because sometimes they'll give you the question and then they'll give you an interval, right? You can give you the question and then give you an interval. You can say just like what we solved now, s cubed minus s squared minus 5x and what? Negative 2 comma 5. And you don't have any, there is no stress here, especially as you have been asked to determine the relative minimum or maximum. So what happens here now is that, looking at what you have, right, there's a theorem that says that if you have a closed interval, right, and the function is continuous in that closed interval, then it attains both the maximum and minimum points within that interval. Do you understand? So getting the relative mean is just by following these steps I've explained, but is of critical importance maybe if you now want to determine the absolute maximum or minimum. But them giving you this is an indication that, okay, yes, the relative minimum will actually be achieved within this interval. Do you understand? So with that, I want you to pause the video. I want to write down this question and you should be able to tell me if this should come out in the exam. And you're giving f of x is equal to 4x cubed plus 9x squared minus 12x plus 13, and the interval given to you is minus 3 comma 2, right? It is continuous within this point because this is a polynomial function, and if you watch my videos, I've said that first of all, the domain of a polynomial function is what? All real numbers. It's continuous, right, for all real numbers. So within the interval negative 3 comma 2, what can we see here? And it's continuous. So what we can see here now is we get the first derivative and you're asked to get the relative mean and max. Pause the video and attempt, please. So if you have to get that first derivative, the 3 comes down, right? So it becomes 12x squared plus 18x minus 12. Differential of the constant is 0. So equate the first derivative to 0. That will be plus 18x minus 12 equal to 0. Then dividing through by 6, because 6 can go through all of them. What are you going to get? S squared plus 3x. What am I doing? This is 12 divided by 6 is what? That's 2x squared plus 3x minus 2 equal to 0. So you look for two numbers, you multiply, that you get minus 4. That's 2 times minus 2, and that you add, and you get plus 3. And that's simply minus 1 and plus 4, because minus 1 plus 4 is what? Plus 3. So 2x squared minus x plus 4x minus 2 is equal to 0. And then on factorization, x is common. X into 2x minus 1 plus 2 into 2x minus 1 is equal to 0. collect this, and that's what are you going to have? X plus 2 into 2x negative 1 is equal to 0. And that means that x is equal to negative 2, because I'm just equating each component to 0. X plus 2 is equal to 0, and then 2x negative 1 is equal to 0. So x is equal to negative 2, or x is equal to 1 over 2, right? So the question now is, given this as f of x is 4x cubed plus 9x squared minus 12x plus 13. We then have to get f of minus 2, which is the first critical point achieved, and this, so that we now know which one is the relative mean or max. So at x equals to negative 2, we have 4 into negative 2 to the power 3 plus 9 into negative 2 all squared minus 2 into minus 12 into minus 2 plus 13. And this is 4 into minus 8, right? Plus minus 2 all squared is 4. 4 times 9 is what? That's 36 plus 24 plus 13. And that will be negative 32, right? Plus 36 plus 24 plus 13. And negative 32 plus 36 is actually 4, right? Negative 2 plus 36 is 4. Then plus 24 plus 13. That's actually 28 plus 13, right? Because 4 plus 4 is 24. 4 plus 24 is 28, right? And then 28 plus 13 is what? 41. So our first critical point is negative 2 comma 41. Mark that. And then at f, what was the other critical point? We got f half, right? So if you substitute f half in the original function, which is what? 4x cubed plus 9x squared minus 12x plus 13. What are we going to have? 4 into half to the power 3 plus 9 into half squared minus 12 into half plus 13. So if we then simplify this, that will be 4 into 1 over 8 plus, because 2 to the power 3 is 8, and then 9 into 1 over 4, because 1 over 2 squared is 1 over 4, and then minus 6, and then plus 13. Right? So 4 into itself 1, 8 divided by 4 is 2, so that we have plus 9 over 4. Negative 6 plus 13 is what? Positive 7. Right? So dividing through by 1, that's getting the LCM, is going to be 4. 4 divided by 2 is what? 2. 2 times 1, 2 plus 4 divided by 4 is 1. 1 times 9 is 9. Plus 4 divided by 1, 4 times 7, that's 28. And 2 plus 9 is what? 11. 11 plus 28 is 39 over 4. So the other point we are having is half comma 39 over 4. Right? So that's going to give us 9. Yeah. So this is the other point. So which of them is the mean or max? I want you to be able to tell me. Right? So remember that the first derivative was 12x squared plus 18x minus 12. Second derivative, first derivative was 12x squared minus 18x plus 12. And then if we get the second derivative, 2 comes down, right? So it becomes 24x minus 18. So test these values. At x equal to half, what are you having? So there was 24 into half. I'm testing these critical values. 24 into half minus 18. 2 into itself 1. 2 into 24 is 12. 12 minus 18 is what? Negative 6. You can see that the second derivative is less than 0. Then our second derivative at, what was the second point we had? Remember we had minus 2, right? Minus 2 as one of the critical points over here. Right? So if you substitute minus 2, what are you getting? So that will be what? 24. That's minus 2. And that's 24 into minus 2 minus 18, which is minus 48 minus 18, which is what? Negative 56. So you can see that when half was substituted, what are we having here now? Because you can see there's a discrepancy somewhere. So sorry for that. Let me see. The first case is 8. That's where the issue came from. The first derivative is 12x squared because when we differentiated the first time, it's 12x squared plus 18x minus 12. So sorry, viewers. Right? And what I wrote here is 12x squared minus 18x. Sorry, it's supposed to be 12x squared plus 18x minus 12. So let me move everything over here. 12x squared plus 18x minus 12, and then if we get the first derivative at what's the first point? Half. So if we have the second derivative now, it's going to be 24x plus 18, right? So at half, what are we having? 24 into half plus 18, which is going to be what? 30, because 2 into itself 1, 2 into 12, 24 is 12, and then plus 18, 30. But at minus 2, what are we having? 24 into minus 2 plus 18, which is what? Minus 48 plus 18, which is minus 30. So since the second derivative is greater than 0 at x equal to half, that means that it is a minimum point, and at x equal to minus 2, the output was minus 30, and since minus 30 is less than 0, is a minimum. So in conclusion, you can see that the relative mean is half comma what? When we substituted half, what was the output? 39 over 4. You can see half comma 39 over 4. I know if you convert this to decimals, you can actually see 0 0.5 comma 9.75, right? And then the relative max, which occurred at minus 2, that'll be minus 2 comma 41, and that's the relative maximum point, right? The next thing we are going to look at is the absolute mean, and I want to take this over to the next video, right? So I want you to watch the next video. The next video will focus on how to get the absolute max and mean of a function. With this, you should be able to answer any question given to you on determining relative mean or max. Thank you so much for watching this video. I'm so grateful, and I believe that any question that comes on this, you'll be able to answer it. Thanks once again, and have a nice day.